Right. In the previous class, we saw an introduction to Border Gateway Protocol, where we understood the concept behind the protocol BGP. The idea is between the autonomous system, we need a protocol which is more flexible in in providing the policies while picking up the path. So BGP is the best protocol to provide that facility, which is more flexible. The reason is BGP has got a lot of attributes instead of metric. BGP is the best between the border, between the autonomous systems, where a lot of policies in path selection need to be applied. And we saw the different ways in which the routes are learned using BGP in a multi-homing environment. We learned that multi-homing is an enterprise is connecting to more than one ISP, like 2 or more ISPs. I have seen connecting to more than 5 ISPs, up to 6 ISPs also I have seen. So that is what we called as multi-homing. Wherever multi-homing is there, you have multiple paths for the destination, and you have a policy in using these paths for which a protocol like BGP is the best because it has got attributes. BGP is not going to prefer the path based on the cost or the bandwidth or the delay, but it is based on the attribute. Now, the advantage of having multi-homing is reliability and performance. If one of the connection to one of the ISP is failing, the backup is there, the other path. Or if for a particular destination, if one of the ISP has got more, just for understanding, I'm saying more cost, you can take the other one which is cheaper. In that way, the performance can be improved. So multi-homing is connecting to more than one ISP. That is the place where BGP well fits. So we learned different ways in which the routes are learned: full routing table, partial routing table, only a default route, and so on. We also learned what is an autonomous system. An autonomous system is the group of devices that are under single technical administration, group of devices with the networks, with routes, which are managed by a single technical administration. So when you have multiple networks within the autonomous system, you need an IGP protocol to find the best path. Now, talking about the network between the autonomous system, we use BGP. IGP example, you see there in the cloud in the left, version 2, ISIS, OSPF, and EIGRP. As I said earlier in the previous class, BGP also guarantees a loop-free routing like any other protocol, like all other protocols. How? BGP uses the AS path number. For example, when a network is advertised, if that same network comes back, D won't accept it because it comes with the autonomous system from where it originated. When D finds its own autonomous system as the originator of this update, it will not accept it. That's how it prevents loop. So AS number, autonomous system number, is helping to prevent loop. Now BGP is a path vector protocol. BGP, like you say, distance vector for RIP and EIGRP. This is path vector. The reason is this. When this network is learned here, it shows the path. It says, I learned it from 64520. That autonomous system learned it from 64600. And that autonomous system learned from 64700. It shows the autonomous system via which this route arrived here in 64512. It's a path vector routing protocol. Here, you may have 100 routers inside. You may simply have 2 routers inside. That doesn't matter. It is only seeing as one autonomous system. One hop in BGP, one hop is one autonomous system. In BGP, one hop is one autonomous system. All right. So the difference between IGP and BGP, IGP announces the networks that are within this autonomous system, and it announces the network that has got less metric, small metric, shortest path. BGP announces the path for the network that is coming from another autonomous system at the end of this path. This is the end of 64700. In that end, these are the networks. And it describes the attribute. See, this is AS path attribute. It describes the path via which it has come. This is one of the attribute. AS path. AS path means what? Autonomous system path. So when BGP announces a network, it's not simply sending one small metric along with it, like RIP's hop count or EIGRP's advertised distance. BGP advertises a big collection of attributes for each network. OSPF will simply advertise small metric along with the network called cost. That link state advertisement of OSPF brings what? Cost. EIGRP brings advertised distance. RIP brings hop count. BGP brings attributes. It's a very rich metric. It's not a tiny value like a metric. It's a big value. Attribute. So BGP is the best because you have attributes. Using attributes, you are allowed to define the policies for how the data will flow, via which path the data should flow through the autonomous systems to reach the network. You see, this shows that this is the path it should go. What does that mean? It means that this is not the recommended path. BGP allows the administrator to define the policies to say how the data should flow through the autonomous systems. Through the autonomous systems. It is not just through 10 routers. It is through the autonomous systems. It is crossing continents, countries and continents. We are talking about your path across the continents, across the globe. BGP is a bigger picture, should have a bigger picture. Not just, within a small office you're dealing with the internet, the big network. Yep. So attributes are not just a tiny, like what you have in OSPF and RIP and EIGRP. All right. So BGP is a path vector routing protocol. That's what we saw in the previous page. Now here, what it explains is one hop is one autonomous system. See, you may have 100 routers, but here you may have only one router each. But it won't take this path. Why? The number of router is not focused. It focuses on only the AS number of AS. If I go this way, it is 1, 2, 3 hops. If I go this way, it is 1, 2, 3, and 4. So when you don't tune attribute, most of the time the path selection will be determined. Path will be selected based on the shortest AS path most of the time. When there is no other attributes are tuned by us, there are many attributes we will be learning later. 0 to 11 attributes we have. And when you don't tune them, most of the destination path is determined based on the shortest AS path. And we also saw these things in the previous class where BGP is appropriate. Whenever you have multi-homing, whenever you have a transit. What is transit? Let's take this picture. You see, to reach this network from here, if you want to reach this network, your packet need to go through this guy and this autonomous system and this autonomous system. Why should they give their bandwidth for you to go from here to there? Why should this autonomous systems in the middle share their bandwidth, share their resource? Why should they route your packet? It is because you are paying them. You have taken the internet connection. You are paying them. So according to the subscription policy, according to the money that you paid, you will have a policy for your traffic. There will be a policy. So that is what we call as transit. Your traffic is passing through, transiting via their autonomous system. And AS allows the packet to transit through to reach other autonomous systems. In that case, you need BGP because you have policy there. When you have multiple connections, also you will have policies because you want some traffic to go via ISP A, other traffic to go via ISP B. So there is a policy, you need BGP. Now this below 3 line says when BGP is not appropriate. If the administrator do not know much about attributes, if administrator is not aware of the attribute list and the difference from one attribute to the another, which means he has got limited understanding of how to use the attribute in route filtering and in path selection using BGP. So if there is a limited knowledge of BGP, not in depth, just he knows only to configure BGP. No, that's not the right person. He's not the right person. He's not the right person. If he knows only to enable BGP, like you enable OSPF. If someone knows only to enable BGP, like enabling OSPF or EIGRP, then the person is not the right person. Secondly, there is no multi-homing. You got only single connection. Thirdly, the router that you are running is poor memory and processor. Then you need to think twice. The reason is BGP is going to take more processor and memory depending on how many networks you learn from another autonomous system. More the networks, more CPU and memory is needed. Now BGP is a path vector protocol with the following enhancement over distance vector protocol. Distance vector protocol like EIGRP, they don't use TCP, but this uses a reliable way of forming neighbor and sharing the route updates. It uses TCP, and the port number that is dedicated for BGP TCP sessions are 179 is 179. And BGP sends incremental and triggered update only, meaning it's not going to send any periodic update. BGP sends keep alive messages. Keep alives are connection oriented hello packets. See, in OSPF we have hello packet, but it is not connection oriented, it is multicast. Here the keep alives are connection oriented. And then BGP has got rich metric called attributes. Using the attribute, you can tune the path. Because this is having a lot of attributes, it can solve the problem of the internet. That's why it is, say, designed to scale for huge internet. So you can call it as a protocol of internet. all the necessary policies in the internet can be easily applied using this BGP path attribute. BGP also maintains neighbor table like EIGRP OSPF. The command is show IP BGP neighbor. There is also another command show IP BGP summary. That will also show you the neighbors. This will be too detailed. This will be, as the word said, summarized in a small table form. When you type show IP BGP, then you can see BGP table, where you will see all the routes that are learned via BGP and the attributes attached with those routes. You can see all the attributes there, like local preference, weight, MED, metric, origin code, next hop, and so on. You will also see when you have multiple paths, one best path elected according to the attribute. And that best path will be seen also in the routing table. BGP sends some messages, and they are of 4 types. Open message. See, once the three-way handshake happens, see, it's a TCP protocol. Three-way handshake is must. Once the three-way handshake is successful between two peers we will configure manually. I repeat, it's a TCP protocol, right? The neighbors are not discovered dynamically. See, in OSPF, we don't configure neighbor. In the EIGRP, we don't configure neighbor. But in BGP, you have to. The reason is, BGP is a TCP-based protocol. It won't do multicasting. It won't learn neighbor through hello packets. There is no concept of hello packets. You have to configure neighbor manually. When you configure neighbor manually, three-way handshake first will be initiated between those two neighbors using the port number 179. If both sides are properly configured, the three-way handshake will be successful. And then the first packet will be open message, open. After successful three-way handshake, open message is sent. These open messages carry hold time, which is 1/82, and the route ID. Hold time and route ID. Once the open message is sent and then open confirm is also done from the other neighbor, the keep alive packets will start going. This is TCP packet, TCP tiny hello packet. We don't call it as hello, we call it as keep alive. And these packets are sent every 60 seconds between the neighbors that are established.
Hello, sir.
Yeah. Next is the update packet. Update packets are sent only with the neighbor uh, with whom the three-way handshake, open message, everything is successful. Updates are sent. The update is nothing but the routing information with attributes. Okay, with the attributes, routing with the attributes. If anything goes wrong for a network or for a neighbor, for a router, that will be sent as a notification. That's called error message if any error is detected. Update is like sending route information with the attribute, but when there is a change to the update that is already sent, that is sent as a notification. Right. So this chapter was focusing on introduction to BGP. By this time you should know now why BGP. How to configure and all, we have not gone. That's our next chapter. But by this time you should know why BGP is important, because it's a TCP based protocol. We need this protocol between the autonomous system, because between the autonomous system you need a secure protocol, a secure neighborship, secure protocol, TCP based. And also we will have a lot of policies. For that we need a protocol that knows the policies, and BGP is the protocol that knows all the policies. Yeah. So keeping all this in mind, we will go to next chapter in our